In this video, I want to discuss how to find a least common multiple of a pair of terms or a set of terms. This relates to adding and subtracting rational expressions because the least common multiple of the denominators, or sometimes called the LCD, is that common denominator that you're looking for as you rename each of the fractions before adding or subtracting. So here's a definition. The least common multiple of two or more terms is the smallest amount that all of the terms multiply into. So if we're trying to find the LCM of 16 and 20, we could imagine finding this just by trial and error with some expressions. We could go through all the multiples of 16, 32, 48, 64, 80, and so on, and we could compare them with multiples of 20. And we could identify the first number that we see on both lists is 80. So by definition, that's the LCM of 16 and 20. It's the smallest amount or smallest number that both 16 and 20 multiply into. However, that's often time consuming. We can't always write out all of the multiples of the terms that we're trying to find a least common multiple for. So let's talk about a procedure that we can use to quickly identify an LCM. One way to find an LCM, or least common multiple, is to multiply all of the prime factors that you see in any of the terms and use the highest power for each factor that appears in any term. I like this procedure because it allows us to find a least common multiple not only of numbers but also of variable parts. We can use the same procedure for either the coefficient or the variable part of a term. Let's see how this works with finding the LCM of 4x squared y and 12xy cubed. So I'm going to write these out in terms of their prime factors. 4x squared y, I need to break this down all the way. So 4 is 2 times 2, or you could say it's 2 squared times x squared times y to the first. 12xy cubed, 12 is 3 times 4, 4 is 2 times 2, so this breaks down into the prime factors of 2 squared, 3 to the first, times x to the first, times y cubed. So here I have these lists of all the prime factors of any term. The LCM of these two terms is going to include all the different prime factors, so it's going to have 2's and 3's and x's and y's, to the highest power that any of these factors appear in any term. So I need to take 2 squared, these each have a 2 squared, so the squared is the highest power that we see in any single term. I need to take 3 to the first, this has 3 to the first in it. I need to take x squared because that's the highest power, this has x to the first, this has x squared, the highest power wins out. And I need to take y cubed. Taking the highest power helps me to avoid repetition of factors that are already contained in these powers. For example, the x to the first doesn't need to be repeated here because it's already contained in the x squared. So we multiply all of this out, I get 2 squared times 3 times x squared times y cubed, and I get an LCM of 12x squared y cubed. So there we have it. It's a little time consuming, but it always works. So if you're having trouble identifying a least common multiple or a least common denominator by trial and error, use this method and it's a surefire way of getting that least common multiple. Let's look at one more example of finding an LCM so that we practice how this works with polynomial expressions. I want to find the LCM of 3x and x squared plus 6x plus 9. Remember that one way to find the LCM is to multiply all the prime factors that appear in any of these terms. So we need to factor the terms first, then we can compare factors. So 3x is essentially already factored for us. It's just 3 times x, right? X squared plus 6x plus 9 needs to be factored. This is a trinomial. And it factors into 2 binomial pieces, x plus 3 times x plus 3. I could write that as x plus 3 squared. So it's the same factor, it's just repeated twice. So it has a power of 2. The procedure for finding the LCM says we multiply all the different factors to the highest power that they appear in any of the terms. It's important to note 3 times x, those are different factors than x plus 3. They have nothing in common. So the LCM has to contain 3, and it has to contain x, and it has to contain x plus 3 squared. I'm not going to multiply this all out. I would usually leave this LCM in its factored form, and then just, if I'm building up these terms to make this LCM, I multiply by whatever is missing. So this one needs to be multiplied by 3x to make the LCM. This one must be multiplied by x plus 3 squared to make the LCM.